In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice, a flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows.
It's not much of a battle. It's more like the one-sided, straight-up rape evisceration of the beams.
All right, gentlemen, we're live.
Hello. Welcome to Aether Roundtable, or rather Aether Cosmology Roundtable number 48. We're going to talk about the Battle of the Beams. Also, we also refer to this as or has been referred to as Nicobane or Nicobian, which is the German radar system. And so, or really, it's more of a German target finding system using radar. And so, without further ado, Alan's going to go ahead and kick off a fantastic presentation on the topic. So go ahead, Alan.
Thank you, sir. Quick note on the Nicobine system. We all colloquially agreed that we're going to call it the Nickelback system. So if you hear Nickelback throughout this presentation, you'll know that that's interchangeable with Nicobine. All right. So this is a look at the Battle of the Beams. This is the German radar system that defeated Britain's first line of defense, which was Earth curvature, or the assumption that Earth curvature would protect them. So we'll take a look at the characters throughout the story here to build the base. Then we'll get into the tech specs of the radar system. We'll get into the planes that utilize the system. Then we'll talk about the bombing campaign and the, how this operation was executed and what that means for the geometry of the supposed globe. So here we have R.V. Jones. This is the military intelligence officer that was in charge of the investigation for the beams. He came across a series of circumstantial evidences that he presented to Churchill to make his argument that there was an existence of the beams. So we'll get into all that. This is Frederick Lindemann. This is the scientific advisor for Churchill. He enjoys eugenics, science, long walks on the beach, and he worked for Churchill. And to get to Churchill, you had to get through him. Now, luckily, R.V. Jones was a student of Lindemann, so they had a little personal connection there. Then we have Thomas Eckersley. This gentleman his information will be used to present a narrative that this radar system will be possible to work on a globe. And here we have Baron Vladimir Harkonnen, who bears a striking resemblance to Winston Churchill.
Dude, is that not Fat Bastard? Hold on. Go back.
No, dude. This is
the Baron.
Yeah, this is the Baron Harkonnen, right? And this is his brother, Baron Harkonnen, as well. They're twins. So anyway, this Harkonnen was in charge of England at the time, and he was convinced by R.V. Jones that the existence of these beams was a real threat and that should be investigated. And we'll talk about that as we continue on. But it should be noted here that during the presentation from Jones, the scientific arguments for how this would possibly work, mathematically and all that, was not what swayed Churchill. It was the overwhelming circumstantial evidence that was piled up, which we'll cover as we continue. Then, of course, we have the graticule. This is the coordinate system that'll be used by the radar system to dial in the coordinates for the targets. The director beam is faced towards the target, depending on the lat long, and then it's intersected by another beam over that same lat long at a different location. And so the purpose here, right? Most people think that the graticule represents the globe when this coordinate system can be projected on different types of maps. The flat Earth position is that it's the azimuthal projection that's the most accurate. That represents the geometry of where we live, being planar. So we're going to see the distinction here, because if the globe graticule, right, if the interpretation of the projection is correct that it's a globe, then Earth curvature and geometry of that will provide a protective barrier against radio waves. So we'll see how that panned out. And a quick refresher on the graticule. All of these coordinate systems are equally valid. Azimuthal, cylindrical, conical, all these maps are all the same. You can draw distances on all of them, and they'll all be invariant. They'll all be the same. Doesn't matter what projection it's on. They'll all be the same. So we'll read a little bit here now from this. So starting from the theory that the Luftwaffe could project a narrow beam over the country, forming a cross shape in the air, the Germans' planes flew down a route of one radio beam when it met another, and they were playing an X marks the spot game in the sky. Some thought that this would be impossible because they couldn't generate a beam accurate enough with the frequencies necessary to produce this because of the curvature around the Earth. And it was rejected. And the British crews were saying, oh, we get by fine with stellar navigation. Well, that might be true for navigating purposes, but for dropping bombs, when they did a report on their accuracy using stellar navigation, they were off by miles on their targets. It was unusable. And that's why the radar system had to be put forward. So Jones gathers up his circumstantial evidence, and presents it to Churchill and Lindman. And eventually Churchill says, after the war, Churchill described the moment when they had their meeting, and it was like sitting in the parlor room while a great detective reveals the killer, similar to a Sherlock Holmes story, right? He was very mystified by the storytelling ability of the circumstantial evidence. So here we have a list of the circumstantial evidence that I have truncated into a smaller list here that we'll go over in a second. But basically what they found was they intercepted a transmission from Enigma, and it had the coordinates for the two radar systems that were going to be targeting the factory in Derby, and it had the coordinates for the Derby factory and all that. So they were like, oh snap, this is pretty important, right? Maybe this is a threat. And then a German pilot was shot down, had some documentation on him regarding the system that they recovered. And it was about this radar system to Knickerbein. And on top of that, they had shot down a couple of planes and recovered them, and their landing gear was, the transmitters and stuff on the plane were tuned to the frequency tuned to be more sensitive than what was traditionally required for a Lorenz system for the regular blind landing stuff. So it was kind of like they were building all this evidence that, why would you have an overtuned system like that? Like, well, would it be because there's an actual radar system? Like, is this a real threat? So while all this stuff was building up over in the months of June, they finally had their meeting with Churchill and Lindman and the boys, and that's what he presented, right? This is the parlor story of revealing the great killer or whatever Sherlock Holmes stuff, and that's what convinced Churchill to go through with it. And he says that anyone who deviates from searching for the beam and coming up with countermeasures for it are to be directly reported to him. So this became like a top priority situation. So we have the following day after that meeting, a couple of lads went up with planes and ham radios and found the beam signal. So we'll read a little bit of that. They were in the narrow beam 400 to 500 yards wide and were intersected by a secondary beam. So far as known, this was the first occasion that the enemy signals were intercepted by enemy aircraft. So what was going on here is the Germans came up with this radar system, and then they just left it on, while they were testing things out or whatever. And the British intercepted the signals now. So they confirmed that all this circumstantial evidence of beams over the distances that were presented, which we're going to go over here as we go down. We'll get the exact distances and all that. But this was their physical confirmation of the beams. Right, so we have here. So this is about the X-Garot system. So this is the secondary system of the K-Knickerbein. The X-Garot actually came first, but due to supplies during the war and whatnot, it required an extra sensitive receiver and an additional equipment for the bombing computer on board. So this wasn't the primary system that they started with, although this was the original system. But then they came up with the Knickerbein, or the Nickelback system, which used the same landing gear, the Lorenz system, as all the other planes had already been using, but just at a more sensitive frequency. So every plane on deck could instantly become a Knickerbein bomber. All they had to do was adjust their frequency. So that was pretty nice. Now the downside to that was that this would be easy to jam once the British figured it out, and that's exactly what they did. So we'll get into that here in a bit. But here's a look at the radar towers coming in at about 100 feet tall and 325 feet wide, and they rotate on an axis. They don't like this radar system can't be tilted up to the sky. It's just for horizontal propagation, and then it rotates on an axis. So at the locations where the information was intercepted and then, you know, confirmed with the lads in the planes with their ham radios, we got Stolberg at 150 or 143 feet above sea level, and Cleve 275 feet above sea level. And these are the locations of the first two radar systems that were operational in June at the time, that were producing these intersecting beams that the lads measured. So here's another couple of pictures of this radar system, and just, you know, huge. So here we have the minimum and maximum accuracy based on the beam width and how they can adjust the beam angles to get this intersection point more narrowed down. And then here's what we're looking at for June, right? We got Stolberg over here, Cleve over here, and the beams heading over to the factory in Derby where they intersect. Now, the story goes that the British measured the beam width at Spalding to be 400 to 500 yards wide, and then there was another beam at Beeston where they measured that, and we don't have I don't think they mentioned the dimensions for that, but we can math out what it'll be based on the beam specs that are given to us. So we'll get into that. Then, of course, we have the airplanes that are delivering the payload. So we have the Henkel HE 111 bombers. So this is what they were using. These are their specs here. At their maximum weight capacity, you know, carrying a full load of bombs to carry over and drop, they could fly at approximately 25,000 feet. But for the purposes of what was measured and recorded here, they were operating at an altitude of about 19 to 20,000 feet. So, but anyway, you could math it out to be 26,000 feet too. Doesn't help. But this is what the Germans were rocking with at the time when they started. Here's an overview of what the radar system looks like. So the traditional Lorenz system was a blind landing radar system, and the Knickerbein version is the same thing, but it's just inverted so that it goes outwards. So same diagram, but you just flip this plane and have it going outwards instead of towards the runway. You know, same concept. So the signal emits dots and dashes that intersect over each other and create a coherent tone when you fly through it. So as long as the plane hears a coherent tone pulse, then they know that they're flying straight on to their target. Then when they get to the secondary beam that intersects, they'll hear the same continuous tone, but at a slightly lower frequency, and that'll let them know that that's when they should drop the bombs. Now, the problem with this system is that you don't know your true ground speed, and you don't know the exact timing of when you should drop those bombs. So the X-Garot system, which we'll cover here towards the end, how they solve that problem. But this was like a really good estimation for them, and the mileage would vary depending on the skill of the bomber using the system. But this is how they did it. And then, so a plane would take off, fly in the center of this beam, or when they get to the point where they can intersect with it and be in the center of that, they'll follow it out to that secondary beam that intersects with it, and that's where they get their bombing on. We have here, we'll read a little bit from this. It was believed at the time that the VHF transmissions were limited to a range of 20 to 30 miles. So they ended up agreeing about 50 miles for an aircraft at about 2,000 feet. Unknown to the Royal Air Force, the Germans had discovered that with a powerful VHF transmitter coupled with the appropriate aerial array, signals could be received at distances up to 250 miles by aircraft at 20,000 feet. With the aid of a second transmitter located to provide the intersection over the target, Lorenz had developed a blind bombing device for the Luftwaffe, operating at a 30 to 33.3 megacycles and the beam width of 0.33 degrees. This device was given the name Knickerbein. You have your own audio playing on that video, it seems.
Illuminati confirmed.
1 second. Yo, what's the issue, JT?
I hear audio, I think, from one of your videos playing. It's your voice and you're actually live, your live voice.
You've probably got his YouTube feed up in another tab.
Yeah, I don't know. That's not me. Everything's looking good on my end.
I don't hear him. I only hear his voice.
Cool. All right, 1 sec. We'll continue.
It might just be me. I'll check.
No worries, lad. All right, so they did end up having a 3,000 watt transmitter, so that's the wattage on their transmitter, and they mentioned here that it's about 250 miles. But as we get into the distances where these things were used, that exceeds 250 quite easily. So here's just another diagram of that outward projection of the Lorenz system. What it looks like, we got our overlapping beams for the dots and dashes, which creates the coherent equisignal beam, which is what the lads measured. All right, cool. JT says we're all good now. All right, so we have here the interviews from POWs. So quick note on the countermeasures, right? So after the boys measured that beam over Spalding and Beeston, Churchill's next directive was countermeasures. How do we fix this? So the first thing they came up with was radio jamming signals. They were going to emit signals that were about the same frequency, and that would throw the bombers off. And another thing they came up with was something called starfish, where they would light. They had like designated burn areas next to, high priority targets. And when bombings would start, they would light those up, and the coals and everything would burn, create embers. And then you would, the pilots above would see these glowing embers, and they would go, "Oh, that must be where I drop it." So they would deviate a little bit or hold their bomb until they, felt that they were going to hit that pile of embers. So they were using that to create diversions, and then apparently it was pretty successful in terms of the frequency jamming. They even had a couple of German pilots land in their own in the British airfields because they thought that they were over their own territory, which is pretty crazy. But it says here that when they were interviewing the POWs and stuff, they were saying that the confidence in which the Germans had in the system to successfully hit targets was questioned because they were like, well, we don't know if we hit a target or if this is a fake fire, right, set up by the Starfish lads. All right, so, and they started that as early as June, right, because they got that early. They had all that circumstantial evidence before they had even launched their first attack, so they already had some countermeasures for high priority targets, and they already knew where one of the high priority targets was going to be. So we'll get into that now. So we got from Cleve to Spalding, where the first beam was intercepted. It's 472 miles. We have from Stolberg to Derby, which is 451 miles. And we'll get in, I got the Beeston and all that below, so we'll get into all these. And the geometric problems these create. So because we know the bombing altitude, the starting beam specs of 10 meters, and the measured divergence over Spalding, et cetera, we can have the exact amount of divergence that would be required for global or for globe geometry versus planar geometry. So Earth curve calculator says that at a height to give benefit of the doubt to the globe, we set all the elevations above sea level to 656, and that's what we're going with, because that would be the highest of all the ones listed. And then we added, what was it, about 150 feet for the actual tower itself, even though there were only a little less than 100 feet, and some of them were smaller. But we gave
them like 200 feet on. Oh, sorry.
Yeah, you're good. Just keeping it uniform for the boys at a nice 656. So that's going to hit the horizon at 30 miles, just like the lads were suspecting, and arguing exactly why this wouldn't work, because this is a line of sight beam. It's going to go into the sky following that tangent, putting it at 38,000 feet above Spalding. So that equisignal that plane has to fly in to know that it's in that correct spot would be 38,000 feet above the target. You would have to extend it down 18,000 feet to touch the plane, which would make the total beam divergence over target 3.4 miles, which makes it completely unusable. And because those aren't the dimensions that were measured, we know that this isn't the way that the horizontal propagation happened. because otherwise the equisignal would be huge. All right, so good on to the next one. So we have Cleve to Spalding to Derby, right? So this one's going to be the shorter distance from Cleve to Derby. Actually, is that the right slide? So they've got same situation here from Cleve this time. It's going to be 68 or 60,000 feet above the plane, or above Derby, creating a 41,000 foot deficit. And if that was to be filled by diffraction, the equisignal would be 7.8 miles and it would be completely unusable again. And again, we know that this isn't the case because the beam was measured at 19,000 feet at about, 400 to 500 yards. All right, now here's how it would work on a flat Earth. 656 feet above sea level, beam propagates out horizontally, maintains its geometry, and then based off of its divergence, it's going to be 19,000, or at 19,000 feet, there's a 400 to 500 yard equisignal for the signal for 333 miles, or 334 miles. So the flat Earth explanation, it just works. Very cool. All right, and then we have the chronology of the bombings that started. So this system was discovered. Well, the Germans started setting it up in 1939, had it operational in the summer of 1940, which is when it was discovered by the British through the circumstantial evidence, et cetera, et cetera. Then we get into the bombing campaigns that started in July and August. And that's where they started to use these systems to, go after these targets. Now, the first bombing attempt on Derby, they already had their jamming stuff set up, so they missed, and then the bombers kept bombing the like the remains of, or like the fires and stuff that had started from the first bombs that missed. So they completely whiffed on their first attempt there. But this is the system that they used. Then from there, that carried on from August to the following year. There was like 360 days of consecutive bombings. There was only 2 days during that whole period where there wasn't any bombs at night. So at least one bombing a night for 360 days after this, using the Knikkebein and X-Grot systems. And so here we'll read a little bit about the beam dimensions here and how we came up with all that. So fortunately, this period of wretched introspection was dispelled the next day with the result of the search flights was reported. So this was him feeling anxious about, because he was the this RV Jones guy. He was the only one that saw the vision, that was like, guys, there's definitely a radar system. Everybody else was like, nope, it's a globe. Get out of here, kid. Get out of here, rookie. You don't know what you're talking about, kid. That kind of stuff. So he was like, oh my God, did I just waste my whole career hinging it on this radar system? But anyway, so they found it. So we held a meeting at Joubert's room the next afternoon. The pilot, Lieutenant Buffton, was there to tell us what he had found. Neither he nor the Corporal Mackey had been told about the Knikkebein story, or the Nickelback story, depending on who you're talking to, but merely searched for the transmission with the Lorentz characteristics to locate the equisignal after taking it from Witten and flying northwards. He reported that the narrow beam was approximately 400 to 500 yards, passing through the position of south of Spalding, having dots to the south and dashes to the north on its bearing of 104 degrees minus 284 degrees T, whatever that means. And then it says the carrier frequency.
Those are 180 degrees separated of the same trajectory. One is 104 to the east, 284 to the west.
Thank you, sir. Then she says, number two, that the carrier frequency of the transmission on the night of 21 to 22 June was 31.5 megacycles, modulated at 1150 cycles, similar to the Lorentz characteristics. And three, that the second beam, having the characteristics with dots and dashes to the south, synchronized with the southern beam, apparently passing through the points of Beeston, where the bearing lie between 60 degrees and plus and less than 100 degrees And the guess about Derby was a good one. So if you Google map that, what was it? Beeston's about 50 miles to the east of Derby, and Spalding is like a little to the south by about the same. So they were dead on. So here we have again, says, there are many lessons of history, most of which are too obvious to point out. It shows that the German technique is well developed, almost beyond what we had thought possible. If they can place an aircraft within 400 yards over this country, they may well have an extremely accurate RDF or system of RDF, and one might guess that they are concentrating on the CHL principle. The possibility that the Knickerbein is an elaborate hoax may be discounted. At least 16 independent sources have been obtained, and while some of them could be conceivably have been inspired, the physical evidence and the sharpness of the beam, which would have never been gratuitously revealed, and of the increased sensitivity of the Lorenziever are too subtle for the German thoroughness to have been executed. So Lindman immediately said that the beams. So this is going back to how the British are going to explain this, right? Because they present it through the story of the Secret War and the Battle of the Beams and all this, and they make a couple of brief cliff notes on the debacle between how they all disagreed that this would never work because of Earth curvature, yet the signals were measured and the bombs were bombed, or the bombs were dropped over targets that was accurate. And so we're going to get into how the British tried to explain this. So Lindman immediately said that the beams would not work for radio navigation because they would use short waves and they would not bend around the curvature of the Earth. And R.V. Jones says that he's armed with Eckersley's computations. I told him that contrary to what he supposed, they would. And then when I returned to my office to take stock of the situation. So throughout his interviews and various books, he makes non-specific claims about using Eckersley's papers and Eckersley's computations to argue the scientific correctness of how this would work on a globe. But as we went over earlier, none of that mattered. Nobody in the room was convinced. The only person in the room that mattered was Churchill, and that guy was convinced by the amount of circumstantial evidence that was put forth. So we'll get into the papers here that are mentioned by that are mentioned by Jones that were written by Eckersley. So he has two papers. One is called Shortwave Refraction and Diffraction. Neither of these papers, or this paper doesn't provide any give any explanatory power to how this would work on a globe. This is a line of sight radar system. This paper is about omnidirectional burst, going in different. It's not talking about maintaining a coherent beam and then flying a plane through it. It's like, if we put a bunch of power into it and send it off in different directions, is somebody going to receive it? Like that kind of stuff. So not analogous. And then the second paper, shout out to Ruhif, was paywalled, and he forked up $30 to get that paper out. Actually, that was this one. So this was the one that was paywalled. So no explanatory power given in this one. And then the original paper that we found was regarding sky propagation for bouncing and skipping, obviously unrelated to a line of sight targeting shortwave system. This is
Why would that be not used for the planes? Why couldn't they bounce it off the sky?
Because the planes had to fly through it to know where they're at. So in this system, it's going up into the sky. The planes don't fly that high. They flew at 19,000 feet. So if they were to use this,
so basically you should have skip zones, and with the way the system works, you would have a continuous tone. So you would hear it going in and out through skip zones. It wouldn't really be a reliable system.
Yep. And then
so if it was a bounce, you wouldn't get it like the whole middle. You'd get it the beginning and the end, but the middle you'd have no signal.
Yeah, you would run into situations where, so you would be flying towards your target, right? And then you would just have nothing. And then you just have to hope that you're still going in the correct direction, and then it'll pick up again. But it might be like, because of the way that it would bounce and the distances, right? Your next bounce might be directly over target, or this doesn't work this way. This isn't the way that the system was designed. It's not analogous to it. So there's no explanatory
Just take
power.
a look at the elevations they're using. The altitudes, 100 kilometers That's 62 miles up in the air. And it's going past that by a factor of another 200% in altitude before it comes back. It's totally unusable as a focusable anything in terms of EMF.
Agreed. And this was what was put forward, for the story, right? Because like I said, throughout the interview and throughout the documentation, they never get into any specific details of how this would work. Eckersley's calculations didn't redefine all of radio propagation after this. He wasn't given any special awards for discovering how a line of sight radar system could be used for 400 miles. There's nothing here in regards to that. So here we have
that 100 kilometers. Sorry, Alan. That 100 kilometers, just to break it down, is like 300,000 feet just to the dotted line.
Yeah, it's insane. So we have one last thing here. So perhaps the Germans had a secret mountain that was as high as Mount Everest, and they had their radar system on top of that. Would they still be able to target Lee, or would they still be able to target Derby from Stolberg if they were on top of Mount Everest at 30,000 feet? They would hit Earth curvature at 212 miles, and it wouldn't work either there. There would be a discrepancy of 38,000 feet that they would have to account for, which would extend the equisignal beyond the usefulness. So it wouldn't even work on Mount Everest. Now, there's a final claim, the Hail Mary for the globe, is that in this documentation, it's stated that the 0.05 degree fine director beam was so narrow that in calculating its bearing, 5-figure log tables had to be used and taken into account for the fact that the Earth is not a perfect sphere. It's slightly flattened at the poles. So what they're referring to here, basically, right, since this is a line of sight radar system, they're not talking about banking a shot or anything like that. They're talking about lining it up directly over where it's supposed to be. So they're using the graticule, right? They're using the old lat long, but we know that was that's built upon deflections of the vertical, which is where you go to take measurements of where the stars are at your zenith, and they're not where they're supposed to be. So what they did was they said, oh, you know what? The gravitational potential of the Earth must be off at this location. So we're going to go ahead and tilt our theodolite to put it in alignment with that star. And then we'll use that deviation for spherical excess calculations. So they have a compounding issue of corrections that were made. So when they talk about how they have to like align this a little to the left, a little to the right to get this in, this is like deflection of the radio vertical. It doesn't mean anything for the globe. Like this doesn't help at all. That's crazy. So yeah, when you get into deflection, what's up?
But are you sure it doesn't help? Because they said it like 7 times and posted a bunch. So are you sure that it doesn't mean anything?
Yeah. Again, deflections of the vertical are completely unsubstantiated. And when you get into GPS and gravitational redshift, if these gravitational anomalies existed, there would be latitude-dependent redshift calculations that are pre-cooked in to compensate. Like, oh, hey, when you're in this location, right, you're going to be experiencing a gravity anomaly that's so strong that it caused us to have to deviate a plumb bob by 30 arc seconds.
Are you saying that the equipotential gravitation only has issues at ground level when using theodolites, but it dissipates completely up above where satellites are concerned? Is that what you're saying?
Yes. So that's
crazy.
So all that means, right, is that these corrections were, put into the coordinate system because the coordinate system works, right? But certain locations are off a little bit based off of how they did this deflection of the vertical to put that to physically put that star under their location by tilting their own theodolites. So all this is again just correcting a little to the left or a little to the right.
Question real quick. So
Yes.
basically the reason that they had to do these minute corrections is because they have a lat long map coordinate system that works, but when you're shooting straight lines over 450 miles, you might end up a few arc seconds off to the left or the right based on the deviations of the lat long system to the true physical shape of the Earth map.
Yep. 0.05 of a degree off over that or whatever.
Yep.
Okay.
And then so we'll take a quick look at the X-Garage system. So this is how they fixed that timing issue that I was talking about earlier that the Nickelback pilots were having issues with. So they have a director beam that the plane flies through, and then they have 3 transverse beams that intersect it. Now the first beam is your ready up beam. The second beam they cross triggers a timer, and when that timer goes down, or sorry, from the ready up beam to the second beam, their absolute velocity is determined. And from that, when they hit that second beam with their absolute velocity, their onboard mechanical computer system calculates based on their velocity and altitude when they should hit their next drop. So it starts a timer, and then they cross this second intersecting beam, and then that timer counts down to 0. When that timer gets to 0, they release their payload, and based on their velocity and altitude, that they'll be the chances of them being on target are way more likely. So that's how they solve that. So when they talk about, oh, we had to move it a little, we had to do a 5-figure, whatever, dude. It's just a little to the left, little to the right, dog. It ain't nothing.
I'm not seeing how the Urso blatantness is causing that correction, to be honest.
Yeah, me neither. So that's the entire presentation. If there's any questions, comments, concerns, we'll now open the floor to the boys.
Nice. We got a full house tonight, bud. What do you guys think?
Nice presentation, dude. Seems like a silver bullet.
Yet another one.
Yep.
The only explanation you can really try to give for this one is a refraction explanation, because you can't use skywave propagation because, first of all, it happened for over a year, so you can't say, oh, it was magically the time of year when there was a really intense ionosphere and 33 megahertz wouldn't penetrate. Like, it was reliable all year long. They were bombing, so you have that working against it. And then it's also like, it's not just that 2 beams have to refract around the globe, but it's 2 different beams from 2 different stations, 2 different places, and their alignment, the alignment of 2 beams is, such that the plane can fly and hear the singular tone the whole time. So that means that the 2 different beams that are, not situated, perfectly in line with each other are refracting in line with each other around a globe. So it's like you're asking to use refraction. You're like, you have 2 things refracting in unison from 2 different points, and they're curving down together in a way that keeps the singular tone together. It's not a satisfactory explanation as far as I'm concerned.
Quite right. And those 2 points are massive differences apart from the target by a factor of almost 50%.
Also, it's not even I don't even think refraction with an R is touted as a possible explanation, because this is VHF waves, which would not be subject to refraction in that way. And even if you assumed that they were subject to refraction in the same way that visible light is, it's like way, 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 way not enough. But secondly,
I think the term was diffraction.
Diffraction. So diffraction would be the spreading out of the beam as it goes further away. It gets wider. But the reason that doesn't work is, number 1, based on the necessary accuracy requirements of the system, and number 2, based on the actual measured beam width that the British picked up. When they found the beam, they tracked it and traced it and measured its width from 270 miles away at 400 to 500 yards.
Right.
So actually, no, the diffraction would actually be the bleed over the curvature of the Earth. It's a vertical component. And people who make that assertion don't really think anything about signal attenuation. That if all of this bleeding is going on over the surface, then by the time, the alleged beam gets to where these planes are, there's no signal strength left. It's been bled across the surface, according to that geometry anyway.
And diffraction occurs radially.
Have you seen anywhere that published the field strength of the detected beams by the British?
One second. The diffraction occurs radially as well, which is in every direct. Like that's how diffraction works. When a wave spreads out, it spreads out like in every direction.
That's dispersion or diffusion. Dispersion. But no,
Yeah. Well,
diffraction has to do with coming around and bleeding over an object.
well, diffraction
It's
is just
a wave
divergence
function.
past an object. Like the beam is diverging. It's diverging because it has a width. As it goes further away, it gets wider. But when it encounters an object like the horizon, and then goes past the horizon, it continues to diverge, and then the divergence fills in the gap, and that's the phenomenon we know as diffraction. It's the filling in of the cutoff part of the signal. But either way, whatever terminology you use, diffraction or divergence, in order to say that that accounts for the massive tens of thousands of feet difference in the altitude of the beam versus the altitude of the plane, you would have to increase the width of the beam by that same amount in order for the beam to reach down. So it is a geometry problem first and foremost before it has anything to do with signal receptibility or strength. What were you saying, Bull Knight? Sorry, I didn't mean to cut. Like I just wanted to finish my thought.
Yeah, I wish there were signal strength measurements that got logged when they detected the beams, because that would have been really telling. Granted, they were in a hurry; they wanted to not get their shit bombed.
Wasn't it 1,000 watts or something like that?
That's the transmission strength, but I mean the field strength that there was on the far side.
So, Alan, I'm glad you pulled this up right here. So how could you explain this right here, Bull Knight?
Which this?
Right here. Do you see what's on the screen?
Oh, sorry, I was looking at voice. Yeah, I'm about to put a picture in chat here. Yeah, shit, where'd it go?
Is it a geometrical argument or a signal strength thing?
Hey,
Right. That's another good question.
It's an antenna transmission characteristic argument. Not argument. Open question for the forum. So this is the horizontal view of the nickelback's radiation pattern. The circle with the blue trace on it.
Mm-hmm.
So it's a logarithmic based polar graph. Obviously, 0 is the zenith, and then the ground is at 90. It's a relative transmission strength for each angle, right, along this axis. I've got the beam width of a radio signal is usually defined by where it's -3 dB from the max. So you can see there at 87 degrees is the bottom portion of the main lobe, and the max bulk of the transmitted signal strength.
So you're talking about 3 degrees above the horizon, right?
What was that?
So it looks like this focus is a cross-sectional, and you're talking about how the strongest signal intensities here are at about 3 degrees above the horizon. Yeah?
The bottom portion, so it'll be a cone, right? The bottom edge of that cone of most of the signal strength is 3 degrees above the horizon, yes.
Perfect for this task.
On the one hand, yeah, but if you stretch that out over 350 miles, it's going to be 190,000 feet off the ground by the time it's over Derby.
But it's a cone.
No, that's the bottom edge of the cone. See the main where it touches 0, right? That is the absolute maximum gain this antenna system transmits. I've got the model. What angle is that? That is the maximum gain is at 6.5 degrees above the horizon.
So Bull Knight, you're telling me that using this modern day replicated, taking the specifications of the tower, trying to plug it into visualization software and predict what the signal strength pattern would have been, would leave the maximum signal strength somewhere at 190,000 feet. But once again, I ask you, assume that they had an infinitely sensitive, or not infinitely, but sensitive enough, regardless of how weak the signal would have been, receiver to receive the signal. How does the signal get received at all based on the geometry of what's on Alan's screen right now on the plane picture that he has on his presentation. Because
I don't think it works that way, is what I'm saying. So if you look at the transmission pattern, it's not a really tight flat transmission pattern. Like above 75 degrees, there's still a lot of radiated energy.
Just the plane's not up there.
Right, it's not.
So how did the plane receive the signal, Bull Knight?
Hold on. Telling a story here.
Okay.
The to have that much energy going up, it's literally wasted, right? They could have had a much flatter takeoff angle by raising the antenna even higher off the ground, which in my mind would have been how you do it if you're actually shooting parallel to a flat surface across great distance. But this system here sends a lot of it up to 45 degrees takeoff.
Uh-huh. And so how did the plane that was way, way far below any of this receive the signal?
That's the question.
Yeah, I've seen zero evidence that skywave propagation is not part of it. So there's skip zone short range. Yes, there's a short range skip zone. There's even a Luftwaffe manual.
Isn't it very high frequency though, Bull Knight? Come on, bro.
I'm talking VHF. Like VHF and UHF are entirely arbitrary.
Well,
at 31 megahertz is very often, especially more so in winter than in summer. But the Nick and mine was all of this happened in the winter of 39, 40, right?
Went on for a year.
Okay. So yeah, just
every
real quick
day.
before we go on a rabbit trail. Ionospheric propagation, skywave propagation, is not the purported way that this worked. It was claimed and documented as being line of sight. If it was skywave propagation, where we direct our bottom 35 degrees, which is the maximum angle that you can deflect off the ionosphere.
No, that's wrong.
Anyways,
the angle is not 35 degrees.
I got you, but the distance, as we showed the chart earlier, you have to reach 300 something kilometers up before it bounces back down, at which point you will already be past the target. So the entire area in between takeoff and arrival would have been a skip zone. They would not have had any signal reception in between.
No, you've got really low takeoff angles to cover that ground.
Ionospheric propagation also, when you shoot something at the ionosphere, you don't take a coherent beam, shoot it at the ionosphere, and then have it bounce right back down at a perfect 180-degree reflection as a coherent beam.
I would love to see evidence of that. I've not found any that there's azimuthal deflection.
Hey, as he's talking, try not to interrupt immediately. That's so annoying.
All right, he goes on for 45 minutes if you don't like. Let's talk. He can bring up a point, and then let's talk about that. It's the and this and this and this, and then we're 8 points.
So we are
write them down. Then it's annoying to hear you interrupt and talk over at the same time. Like either write them down or just don't engage. Then I don't know.
We are asking you to provide a specific geometric argument as to how on a globe, when the line of sight is blocked by the curvature of the Earth, that when the tangent line of the signal is 118,000 feet in the air, that the plane could still receive it at 20,000 feet. If you invoke skywave propagation, which is not the purported mechanism by which this worked, because that is not how a Lorenz receiver would work. If it was skywave, there would not be a continuous signal to travel in. You would not have 300 and some odd miles, 334 miles from Cleve to Derby of continuous signal if it was pointed at the sky on a ball. You have to provide a specific, coherent, geometric argument for how bouncing off the sky would work in this case that's compatible with a ball.
Due to the fact that it's also the case for the flat Earth model that the bulk of the energy is 190 roughly thousand feet above the bombers. I think flat Earth and globe Earth require skywave propagation, and the skip zone is the short range skip zone is a non-issue. I've got a image I'm dropping here. Yeah, this one. So they didn't like take off and immediately pick up the beam. On this page of one of the specification manuals, the red line is the path the bomber takes. They intercepted the beam at the coast, at the enemy's coast was the words they used, and then followed it up from there. And obviously this is an Excarat. Don't interrupt while I'm in the middle of a sentence. It's really annoying out here. They intercept the beam at the coast, so everything but over the English Channel, even if it's skip zone, isn't going to matter. That's where a skip zone would be for an antenna with this geometry. They're just picking it up. And modern day HF radars, supposedly, I mean, they're referred to as over the horizon radars. They have to use skywave, and they are coherent beams, and they measure thousands of kilometers away. Things like ship eddies and ocean currents and very large scale, low amplitude ocean waves in the shipping lanes. So there's no azimuthal. I've looked for like corrections they have to make azimuthal, to the azimuth position of their readings with HF radar, and I haven't found any yet. Totally down if there is. That's what I would have to see. Evidence that there is left to right distortion after an ionospheric bounce.
Okay, so you proposed a picture of a different system showing the near side coast of Germany and the near side coast of England operating a much shorter range on a totally different frequency band. I asked you for a specific geometric argument specifically for the Cleve and Stolberg beams from those distances that could show that a plane would be able to even receive the signal at all continuously from point A to point B on a globe.
I don't believe they did receive continuously point A to point B because
they did.
There was the Luftwaffe training manual. I've got the translation here. I'll pull it up. Where they were instructed to pick up the equibeam at the coast. So skip zones, short range skip zones, and it even has instructions not to try and find the beam close to the transmitter. So I'll find that. But
the beam was 400 to 500 yards wide.
Yeah, 0.03 degrees, right?
No. That's not what the measured width was on the angle. The 0.3 degrees was listed as the maximum beam divergence angle in the documentation recovered from the Germans. That's like their tech specs. Like if I build an amplifier and I say it's guaranteed to put out at least 4,000 watts at 12 volts, it might put out 6,000 watts, but it's rated at least at 4,000. That would be the upper limit on their accuracy. No worse than 0.3 degrees. If you take the actual measured 400 to 500 yard beam over the one that was hit from Cleve to Derby, when they measured it over, what was that city with the S? Spalding? From 270 miles, a 500 yard beam, 400 to 500 yard beam comes out to 2/3 of a tenth of a degree in beam width. So it was actually much more accurate than the minimum accuracy in their documentation. You can do that just doing a simple trig function.
Right.
So if you have a 400 to 500 yard wide beam, okay, that's the width of the beam, 400 to 500 yards, then in order to receive that beam as you fly over, hundreds of miles, you can't be pointing it up at the sky, having it bounce off a 300 kilometer high layer and then coming back down. That doesn't make any coherent sense.
That's how that antenna operated. Like, antenna modeling is a very mature tool.
Dog, you come in here with
hold on.
Oh, no, you talk for like 5 minutes and you will, dude.
Wait. Antenna modeling is very mature.
Yo, damn, dog. I don't care. You correctly?
You come in here with this antenna model right here, with showing a signal strength model. And in this signal strength model, it doesn't even have a distance axis, right? It literally just shows here's maximum power. Hold on. Here's maximum power concentration based on an angle. But I'm looking at that blue line. That blue line is running parallel with the ground at X distance away. I don't know what the X distance is. I'm assuming that your argument is that underneath the blue line, there's going to be extreme power fall off, so that if you're underneath that blue line, you're going to receive very little of a signal. But we don't even know how far out that blue line stretches because it would be a function of how powerful the towers were. If you don't have a distance axis on this graph, even if we granted it and said that this was perfectly accurate and came from the Germans, which it didn't, it was just modeled by some guy who was doing his best job at reproducing it. If we grant it and say it's accurate, we don't even have a distance axis to know. There's a large portion of this which runs parallel and is ever so slightly above 0 degrees. So you just pointing out where the maximum power is doesn't help tell me how far away the signal will be received.
You're entirely misunderstanding the graph.
Okay, so how far out does that blue line go before it deviates from horizontal? Tell me the distance.
It allows you to calculate signal strength at any distance along that angle.
Okay, so that blue line, that right there where it says 3.05 dB, as soon as I get to the right of the B, I see that it's ever so slightly above horizontal. We'll just consider that's the point where it leaves horizontal. How far away is that?
There's no range on this graph.
Yeah, you can't tell me because it doesn't have a distance axis. That's my point. So how are you going to invoke a geometric argument based on something that doesn't even have a distance axis, bro?
The radial
understanding this style of antenna. This is very.
The radial is dB drop.
Yeah, that's a -3 dB.
Yeah, it's dB drop. It's a radial 50, 40, 30, 20, 15. You know what I mean? It's actually almost according to R squared. So as you go farther out, the attenuates.
It's exactly like a microphone pickup diagram. Exactly the same. Even down to the decibels and the how it's
okay. If I could just say, dude, like we don't have any Globers who can refute this, and of them, Bull Knight is the only one who would be able to. So if we could just chill a little bit and let him speak, because he's the only one who's going to be able to offer it. So after this,
yeah, but I gotta also say real quick,
I know.
Bull Knight's normally so chill. The fact that you're kind of not being that way is a tell.
Well,
like I'm just saying, like I'm just letting you know, I would 100% call you right now.
True, but to counter it, this is his best, like his favorite thing in the whole world. We set up a whole presentation about it. Of course, he's here. He wants to talk about it. All right, I'm just saying.
No, but that makes my point stronger. Bull Knight. I'm just saying, like Bull Knight. Just chill, bro. Like just chill, because I was listening fairly. I don't feel like people were attacking you or dogpiling you that much. I feel like you're being a little uneasy. So just chill. It's okay, dude. If the Earth's on a ball, you're gonna be okay.
No, I mean that's my point. Like I am not here to prove a globe. I'm here to offer radio expertise perspective on this exact subject. It is I do like even on a flat Earth with this takeoff angle, I believe it is fairly clear that it requires skywave propagation to get that far. And that's not his model of the antenna. Like that's I modeled the antenna. So we can.
Can you still man the
response?
Can you still man the response as to why they're saying that wouldn't work?
Every time the skywaves graph, well, not every time. A lot of times when the skywave graph gets brought up, it's drawn as if like it's several individual lines and they just bounce off and down and up, right? But the entire region is filled with the signal. It's just a matter of density, like field density, field strength.
So there's not skip zones or dead zones?
No, I mean, I think there would be very close to the transmitter. The reception, the signal strength prediction for Cleve to Derby, it was like 80% without skip zones last time I looked at it. I could run that again and see if it's still the same.
So are you just ad hoc saying that their chart was based on Skywave, because there's literally not one reference in any documentation anywhere on any German paper that says anything about Skywave or bouncing off the sky or the ionosphere. It's not
And
there.
also, that wasn't a stillman anyway, though, right? Like, I'm asking you, can you stillman why they're saying that doesn't work? And then you were saying every time someone shows the graph, you think it doesn't show. I'm asking, can you stillman why the Skywave wouldn't work?
Oh, are you asking me what
the
or him?
proposed
No,
the
no, I'm asking him.
the proposed deflection left and right that might occur is one thing that's brought up, right? That it wouldn't be a quote unquote a coherent beam if it refracted off the ionosphere back down. Skip zones being a second, but that skip zones just invalidating the whole thing. Like there wouldn't be any reception at all if there are skip zones.
But that was the actual stillman I heard, right? Which is like if you actually have to have a consistency of signal to be guided, then you couldn't have skip zones.
Otherwise, it would be reported. They had a coherent signal the whole time, right? That's how they tracked it.
Which is how the Lorentz signal works. Like that's how the blind landing receivers work. You know, a blind landing receiver, you begin getting a signal when you're like 10 to 20 miles out. You know, okay, for the next 20 miles as I approach the airstrip, I have to remain in this beam. And it's not very wide, so as soon as I get just a little bit off to the left or a little bit off to the right, I'll know. Dude, if they were going in like dozens or hundreds of miles without signal across open water or above cloud cover at night, they would easily be able to get off by 400 yards. They'd never find the beam again.
They did a lot of bombing raids before the beams were put up so that they could navigate across the channel and get to a city. So navigating across the channel to intercept a beam is not a stretch.
At night?
Yeah. I mean, they did celestial navigation to do that. So yeah, at night.
No, that's what the British did, actually.
They were going blind.
Too, right?
They were doing it blind. Lights off.
Yeah, this is entirely blind above cloud cover, so they don't get seen by any of the anti-aircraft systems.
They were talking about crossing the channel, though. So there's not anti-aircraft systems floating on a barge waiting for.
Wait, this goes. Wait. Why did you skip past the point? But if, dude, if it's blind, they need a consistency of signals. Skip zones would not be permissible.
Yeah, I've got the translation of from the Luftwaffe manual that says pick it up on the enemy coast. So,
and I can see that there's probably anti anything out there in the middle of the channel. Talking about overland.
Well, so I don't understand the whole bouncing off the ionosphere. So maybe as like someone who specializes in radio waves, maybe you could explain to me, a layman, how these dots and dashes would be able to stay in alignment after bouncing off of some sort of non-physical barrier in the sky and be able to stay within the range, because like the idea is that you've got beeps on one side and dashes on the other. If it's bouncing off of something, wouldn't those switch or get fucked up? Like maybe you could help explain that to me, because it seems to me the dots and the dashes are the tell in this whole thing that keep it so it has to be line of sight, because
incoherent, right?
Yeah, so maybe you could explain that to me, because if you could explain that to me, then maybe you got something there. But it seems to me if it's bouncing off anything, ricocheting, it's going to go in the exact opposite direction that it needs to go.
The antenna array is two separate antenna transmitting elements angled at 165 degrees in a little V shape, and that's why it was bent leg in German. It got the name for it.
That's not actually the answer he's looking for. The real answer, Mr. is, can you hold on, Bull? The real answer, Mr., is that the plane that's about to drop the bombs actually has a total of 4 receivers, receiving 4 different frequencies simultaneously, 2 from each location. And when that happens, what we're actually looking for each one, like let's say A out of A, B, C, and D, is producing the dots, or the ones that you're talking about. The way the dots are produced is simply by a gating of the emission of that frequency. And this is why they were talking about how there's 31 megahertz as the quote carrier, but it's actually being switched on and off at 1100 hertz. That relative frequency and slices thereof to produce a dot signal of the 31 megahertz broadcast. You know what I mean? So that it is not constantly sending the 31 megahertz signal. It is broken up into the geometric by the slower frequency. It is gated on and off, switched. Does that make sense?
Yeah, because I understand like gated on, with audio stuff. So somewhat, yes, I think
Perfect.
I understand. Yeah. But that's still, if he's claiming that this is bouncing off of the ionosphere.
Well, I'm just saying that doesn't affect any of the geometry of the situation. That is the temporal aspect of the situation, right?
Oh, okay. But I guess my question is if he's claiming that it's bouncing off the ionosphere and you've got these dots on the north side and dashes on the south side, how are those going to stay in place, basically, how in alignment with that?
Well, once again, the dots and the dashes are actually just 31.4 megahertz and 31.2 megahertz being turned on and off, at different frequencies, different switching rates to produce the tones that you hear in the receiving end. That's all temporal manipulation. The part that I agree with you, Mr. The part that I agree that he does need to explain is how we're firing EMF allegedly up towards something in the order of 100 to 300,000 feet above, and then somehow the geometry is preserved on in a spherical situation in terms of the vertical component.
Yeah,
cross section. Somehow that geometry is preserved after it reflects back down again another 100 to 300,000 feet towards the aircraft. And he has done nothing to explain any of that geometry and how that might take place on a strata that is so less dense than what we breathe. That we live in the densest air by far, and that is an immense curve and cutoff, if you will, break off as we go into the upper atmosphere. There's nothing up there for it to physically reflect off of. He has provided no explanation for that. So let's see what he has to say.
It's not the density of the ionosphere that refracts it. It's the electron density. That's how conductive it is.
You just used the word density. It's got to exist there somewhere physically, and it doesn't.
Gas pressure? It's not gas pressure.
See, that's what I'm trying to tell you, is that it's not gas pressure.
No,
and if it's not gas pressure, there's nothing else up there to create anything magnetic. There's no physical strata.
There's a conductive field, a conductive layer of ions. That's what the ionosphere is.
Okay, there's no such thing as a conductive field. Things that conduct are physical, like a conduit.
Yeah, ions. Region.
No.
A region of ionized gas that is conductive. Plasma vibrates at of the same frequency, will refract.
Okay, so you're assuming some kind of horizontal charge distribution with no substantiation as to what kind of local phenomenon could create even a remote, close to any kind of thing you would perceive as a gradient across the horizontal to produce polarity.
I think he's talking about a firmament.
If there it is, it's only 100 kilometers up, so I don't.
Well, no. Actually, the heavy side layer is between like 240 and 330 kilometers up, bro. The attenuating layer is 100 kilometers. That's just where signal attenuation begins. That's not where the bounce happens.
It can. The E layer starts there.
Yeah, and it's specific to specific frequencies, and it's also changes day by day and hour by hour and with time of day. There's no consistency to it. It's constantly changing, which is another problem for your geometric argument. But even if we granted it was a perfect mirror and it was consistent all year round, remember 300 and something days straight of bombing, even if which they wouldn't be able to predict the ionosphere, we still can't even do that now. They definitely didn't do it back then. You would need very specific geometry to do something like that. Even if we granted it and pretended that it was consistent the same every day and just was like a mirror in the sky, it still doesn't help your argument because you would only be picking up the signal in 500-yard wide regions across a 300-mile distance. I mean, how many times do you encounter a 500-yard wide signal across 300 miles? How many times would it be bouncing?
You'd have to directly measure that.
Yeah, because I mean, by that plane is flying so fast that if it was a 500-yard wide signal out in front of it that it just passes through for a split second at the speed of those planes, they'd be getting the signal like for like half of a second, if that, and they would be doing that every what, like 200 miles? Like they would receive it twice on the way there. That doesn't make any sense, bro. They flew through a beam. The plane was inside the beam, and they flew through it to get to the target.
The beam is just a left to right area.
Have you seen The Secret War?
It's not from ground to sky. It's not like a vertically constrained beam. Even with the field strength measurements the Germans have, like.
Have you seen The Secret War? Like, have you seen the documentary where it talks about this? They literally hop into it's an old black and white film from the time. They hop into a plane with the receiver on board and they fly in the sky, bro, and they pick up a beam and it's like, duh. And they're like, this is the signal they would have been listening to as they flew from Cleve to Derby. Like, they talk about it in the documentary.
Yeah,
it's a Lorentz blind landing receiver.
Yeah, the POWs and stuff talk about how they, fly through the beam and how cool it was because it took the human air out of it and all this stuff. I mean, like, so, like, just to, like, get this straight real quick, is your argument is that, like, there was just, like, magic zones where an equisignal would be over a target, and you think they just, like, flew over it, and when they heard that, they were ready to rock?
Nope.
Okay, making sure.
I did want to clarify. You said something about it only being like one winter. In the presentation, Alan did say that this happened over a year's span of time. So this was like, not just a few isolated things. Like this went on for over a year. So if you are going to invoke this ionosphere bounce off thing, how are you going to determine that's going to be the same every single day, depending on, because I would imagine that kind of stuff fluctuates with temperature, weather, whatever, if we're talking about an electrical gradient. But I just wanted to clarify because you said, I think what was this, just like a winter? No, it was over a year's worth of bombing, so.
Back to the ionosphere just for a sec.
Let me address that.
Sure, go ahead.
The Knickerbein system itself, they didn't blow up the factory with it. It was quickly shut down by the Germans once they figured out the countermeasures were in place. And then they moved on to the Weigerat system, which they had to deploy a lot closer to the English coast because it used a higher frequency, and that limited the targets they could use it on. It was a more accurate system. They used a phase offset and a two-way signal to do the radio position finding. But the Knickerbein itself was not in use for very long, and it did not hit the factory.
It was in use for a year.
Yeah, it was about a year.
And it only missed the factory because of the jamming stuff. Like, they used it to target other stuff, and they didn't have enough.
And then they built more systems based on it.
Yeah, they didn't have enough equipment to put in the planes for the Excurot, so like that was like a limited use scenario. They had way more. They had way more K-Nix. Sorry.
The Weigerat was like the final form.
Yeah, that was several years later. But like he said, they used Knickerbein for like a year straight, and it was a constant like battle between the British and the Germans. The British would find a way to jam a signal, and then they would throw it onto a different frequency spectrum, and then it would work for a week, and then the British would find that one, and then they'd jam it again, and it was like back and forth, jam and measure, countermeasure for like a year straight. And finally, after they got it like all the countermeasures in place to where they didn't have any more ways to like modulate it or work around it, then they went away from the Knickerbein and started using the other two systems exclusively. But it was used successfully for a very long time, and once again, a 500-yard beam from 270 to 330 miles away does not work geometrically speaking on a ball. It's the geometry that is the problem, and you still have not given not a generalized, just saying, oh, it could potentially work like this if we just imagine a specific argument showing with numbers and specifics how a plane at 20,000 feet altitude could receive a signal that, if shot tangent to the horizon, would be 118,000 feet over their head, or 90,000 or 60,000 feet over their head.
Even on a globe, it wasn't shot tangent to the horizon, though. That's kind of the point of the modeling.
The modeling shows that it stays flat to the ground out to a certain distance, then begins to taper off upwards. And I asked you, how far away is it that happens? Because it doesn't have a distance axis label, and you couldn't give me an answer. You said it doesn't matter. That doesn't even make sense to say it doesn't matter.
It does not stay close to the ground and then taper up. The closer to the ground it gets, the lower the signal strength at a dramatic rate.
Dog, are we looking at the same picture? I mean, I see that blue line running on the x-axis all the way to the right until it gets to where it says 3.05 dB, and then it begins to taper upwards. It is literally running along the ground, that blue line, which is like the distribution cloud of where the signal would be, according to you. So how far out does that blue line travel before it begins to rise up off the ground, was my question, and I still have not received the answer.
Because that doesn't mean anything with this graph. You're just not understanding.
Bro, stop telling me it doesn't mean anything. Answer my question. How far out does the signal have to go, that blue cloud distribution have to go, before it rises up off the ground?
He can't quantify that for you, Pizzo. He's trying to tell you that, okay? Don't stop asking him that.
What's crazy about
His
this
entire argument's
conversation?
irrelevant.
What's crazy about this conversation is, I bet that he's in the exact same position Winston Churchill was in when he was being told, "Yo, they're it's like, no, bro,
it definitely won't work."
This is
And his whole
exactly
team
the
of people are
part.
like, yeah, this is the fucking scene, dude. We're reliving history
Yeah,
right
it's so
now.
funny. It's so funny.
That's exactly what happened.
But his globe.
Can we get back to the ionosphere just for a sec? Because there's this thing he keeps referring to skipping assumptively in a rather glib way. And I'm sure what Bull realizes that when we're talking about a 30 megacycle source and it's going up there in the air, you know, in order for any kind of EM reflective surface to be effective, you know that it has to be operating at a frequency higher than the source frequency, which is 30 megahertz, okay? The question is, which part of the Helio model, which part of the globe Earth model says there's something up there at 100,000 feet operating at over 25 megahertz on its own? Where's that coming from? What are you talking about?
Direct measurement in real time. I've got my own demonstration.
Measurement of what? Whoever sent a balloon into the upper atmosphere and said, "Oh yeah, we measure 50 megahertz up here at 100,000 feet." When did that ever happen?
There's real time monitoring of the return signal.
I'm telling you, there's lots of monitoring. Sure, lots of balloons going up. But
I've got a picture.
Who's registering?
I've got an image of my own direct measurement of it.
Who's registering 50 megahertz naturally occurring at 100,000 feet? I'd love to see that. As well as an explanation as to what's generating it.
So, are you referring to the E layer, Bull Knight? Is that what you're trying to refer to?
The E and F1 and F2. Or if one of them has two layers that collapses at night. So here's the image of my direct measurement of skip zone and skyway propagation. If I can talk through it, obviously, if anyone wants to know.
Yeah, dog. Well, good presentation, Alan. I enjoyed it, dog. You should definitely make this like your pinned post on Twitter and stuff.
Yeah, will do. So, quick recap. 0 geometric arguments provided for the globe. Going once. Going twice. Sold.
Oh wait, I have a meme of how it looks stupid. Ready? There, it could never work. Perfect.
Oh.
Copy paste.
Nice.
I'm gonna right click that one.
How is this on your YouTube video, on your YouTube account? Because I missed it. I was out with my uncle.
Yep, it is.
Oh yeah, brother, I'll catch up.
All right. Bull Knight,
You see
much
what I-
appreciated. Thank you for coming on. We're gonna wrap up here soon. Is there anything else you wanted to conclude or add on before we head off? I got your image up if you want to break that down or what have you. Is this one you're talking about?
Yeah, the larger of the pins there, that's my transmitter's location. This is on
Cool.
10 meter. It's 28 megahertz in this case, but 28 to 31 is it's not a radical change. There's not like a line where it stops working the way 28 works and works entirely different at 31. But all of the lit pins are verified stations that received my signal, only mine. It's filtered by what I transmitted. So you can see there's a handful within, a state and a half, then a big skip, and to the west, and then a bunch of reception on that band on the west coast, west of the Rockies. And obviously a smaller skip to the east, and then reception right on the east coast, and a whole bunch in Europe, mostly due to the time of day.
Now, are
But
those skips, or are those just stations that recorded your signal?
They're all stations that recorded my signal.
So they're not. How can you verify that it's a skip zone that's causing the gaps there, rather than someone just not
You
reporting
can't.
that they received it?
It's
You can't,
automated. And you can look up the map of all the stations that are able to receive signals, and the Midwest is just absolutely full of them. It's a pskreporter.info. I'll drop that link.
No, I have it too.
Nice. Yo, Shane. Did you want to add your geometric argument? I have the screenshot up.
What is my geometric argument?
Jizz-tastic.
Yes, my geometric arguments are based on and based on even their best proposed method of how it could possibly work, i.e., skip method, ionosphere. Like if it would skip once, it's broken. It doesn't work. Right. That's what the meme shows and how goofy it is. So to have it be able to bounce and still maintain coherency, and then have something be able to maintain, like even if it doesn't at the sensor, you don't need to like from the coast on, right? Even giving them that, it has to be in the beam the whole time, or they have no idea where the fuck they are. Has to be in the beam to get the first signal. Has to be in the beam to get the second signal. Has to be in the beam to start the clock. Just saying.
How dare you?
And the reception on the map, it was a digital signal, so it wasn't just like a bleep one tone or anything. It was a encoded digital signal. It was omnidirectional in this case, but
awesome.
Has your sole objective been to just like pretend you're addressing it by making the slightest irrelevant?
It's all good. It's all good. We're about to listen to Man of Stone play us out.
Rockin'.
Where's that new hit single from Man of Stone? Oh, Light Propagation? How entirely relevant. Here we go.
Yeah, that guy's kicking some ass.
That guy's got some special armor.
I wish he would have ended his sentences with "Winston Churchill has spoken."
All right,
Somebody give
lads.
him a cigar.
I'm going to play this out. Oh, but before we go, I'm very parched from all this talk of Knickerbines and Nickelbacks and X-Garots, Y-Garots. Does anyone know where I can get a cup of penguin juice?
Oh, you may want to head on over to brushtail.coffee or brushtail.coffee or brushtailcoffee.com. That's BRUSHTAIL coffee. And you, oh, wow, look at that, the screen share. You can get your exceptional small batch coffee shipped free. I actually roast it myself on the grill with a special drum contraption. It's always roast fresh. I pick really good, high quality beans that are, fantastic tasting, and sourced from processing facilities that are producing very high quality products. Nothing is cheap beans. If you have any questions, a lot of them are organic, but not all of them. Mostly, I'm more concerned with, rather than is it Smithsonian bird friendly and is it, shade grown or, whatever certified. I'm more concerned just with a specific processing facility. So if you have any questions about any of them, you can always ask me, shoot me a message. But also, if you're just looking for some good coffee, try out the Brushtail blend. That's my, quote unquote house blend. I think it's pretty good. But yeah, there you go. Thank you, Alan.
Yes, sir. All right, Man of Stone's going to play us out with a cut off his new album.
Particles of mass that's all round. Talking about light propagation. Something that just can't be found. Talking about light propagation. Acting just like waves too. Talking about light propagation. That's a lie, I thought you knew. Talking about light propagation. Light propagation. How does it come from years away? Talking about light propagation. All that time reaching us today. Talking about light propagation. Gravity don't cause no deviation. Talking about light propagation. That's the deal with light propagation. Talking about light propagation. Light propagation, baby. Light propagation. An isotropic plate is day. Talking about light propagation. Aether's here and it's here to stay. Talking about light propagation. Ain't no crazy postulation. Talking about light propagation. I'm just talking about light propagation. Talking about light propagation. This light propagation. Talking about light propagation. C plus V going up and down. Talking about light propagation. Back and forth to your side of town. Talking about light propagation. Dang Wing had a lot of nerve. Talking about light propagation. Zero motion, straight or talking about light propagation. This light propagation. This light propagation, baby. Talking about light propagation. This light propagation. This light propagation, baby.